Hi everyone, we're on to lesson 2, and in lesson 2 we're going to explore the difference between a linear and nonlinear relation. When I have a graph, it's pretty obvious to see when a function or relation is linear by looking at the points on the graph. So what I can do to prove it, instead of just saying, hey, I know it's linear, what I can do is I can create a table based on these points. And essentially, if I look at maybe these 3 points, -1, -1, 0, 1, and 1, 3, what I can recognize is that there is a pattern in X and a corresponding pattern in Y. And we're going to refer to this now as a rate of change. And this is what it means. When X increases by 1, Y increases by 2. And the main point is that these numbers here are constant. Okay, so when your relation is a line, when you have a pattern in X, you should have a constant pattern in Y. So now let's look at something that is pretty obviously not a line because it isn't straight, it has a curve. And now we're going to look at what happens when I create a table. The main point of this table, or one of the things I have to make sure of in this table, is that there is a pattern in X. So for example, I might take X equals -2, -1, 0, 1, and 2, because that creates a +1 pattern in my X values. Now I want to look at the Y values. What I can see is when X is -2, Y is 4. We've got 1, 0, 1, and 4. And remember, we said X is the independent variable, meaning I can choose it. So I've chosen it so that it has a pattern. Now I'm going to look at Y. Well, I can see that I have -3, -1, +1, +3. Because there is no pattern in my Y values, this is a nonlinear function relation. Okay? And I'm just going to call it now the rate of change, meaning the pattern in Y values, is not constant. So it changes. So when I don't have a graph now, I should be able to see that as well. Let's do 2 more. So I'm going to pick -2, -1, 0, 1, and 2. Because remember, we said our points have to be constant, right? Our pattern in Y has to be constant. -2, -1, 0, 1, 2. -2. Now that one looks a little strange. I'm going to call it maybe -1/4, 0, +1/4, and 2. Okay, so I can see that I'm adding 1 3/4. I'm adding 1/4. I'm adding 1/4. I'm adding 1 3/4. Okay, so again, this is non-linear because the rate of change, we can call it an ROC of Y, is not constant. Okay, this one's a line, and maybe we can pick some more spread out points. Let's pick -3, -1, 1, and 3. As long as my pattern is constant, I'm good. Okay, it doesn't necessarily have to go up by 1s. It doesn't necessarily have to touch 0. So I have 6, 4, 2, 0. So I can see I'm going down by 2 every time. So we call this one linear. And we can see it from the graph. So If I don't have a graph, if I have a table, again, as long as my pattern in X is constant, I can look at my pattern in Y. And let's be careful here because we have to check all of the patterns because we might be getting tricked in a table. So yes, in fact, these are all +3 on the Y value, X values, and +2 on the Y values. So this is a linear relation. Now what happens when they're all scattered around like this? Well, our job is to create the pattern or try to see if there's a pattern by putting these in order. Okay, so let's start at the lowest one, which I think is -12, 2. And then the next one is -7, 4. And then -2, 8. 3, 16. 8, 32. 13, 64. Okay. Now I can actually see a little bit of a pattern. Well, so I see +5, +5, +5, +5. Yep, there's a pattern in X, and there is a bit of a pattern in Y, but it is it's not linear. It's not constant. I can see that it doubles every time, but what we're trying to find is the difference in Y values. So in fact, this is non-linear. And as soon as I did that first calculation, I could say that it's non-linear. Okay? So I just want to summarize what we talked about here and maybe what we're going to talk more about in this lesson. So one way to determine if a relation is nonlinear or linear is by looking at its rate of change. And you're going to see this in years to come. ROC, rate of change, is the change in Y. You might see it written as a triangle. We call that a delta. Okay, delta Y over delta X, which is just equal to the pattern in Y values over the pattern in X values. And remember, X is the independent variable, so that's the one that you pick. That's the pattern that you find. So you choose a pattern in X and you see if there's a pattern in Y, okay? And the word that we're going to use is constant, okay? If the patterns are constant, then it is a line, sorry. Another word we might use to describe this is called the first differences. So differences meaning the difference from one Y value to the next Y value. Okay, so use rates of change, or in other words, first differences, to determine whether the following are linear or nonlinear. Well, we can see here that the pattern goes up by 1 every time if I use the 3 points that are given to me here. Okay, and we can just, if we want, we can put it in a table. Okay, -1, 2, 0, 0, 1, -2. This goes up by 1 every time. This goes up by 2 every time. We know it is linear. All right. I can see pattern in X values for B. For Y, I see +1, +1, then +21. As soon as it does that, I know. I don't know what it looks like, but I definitely know it's not a line, so it's nonlinear. All right, let's fill in a table for this one. Okay, and we can choose maybe 4 values. I'm going to do -1, 0, 1, and 2. So when X is -1, I know that -1 squared is 1, so that's 2. Anything multiplied by 0 is 0. This is going to be 2, and this is 4. Sorry, that is 8. Okay, so I've picked my pattern in X, and I can see this is that's -2. -2 plus 2, already we know it's nonlinear, but we can just do that last calculation. Okay, what about this guy? So what I can do is continue what I've been doing, which is take a pattern in X values, okay, and I can look at a table. Okay, I get -2, -1, 0, 1, and 2. And my Y value is 3 for all of them. Okay, so I can see that my differences are +0. And although it's a bit weird, it is actually technically constant, right? So because the pattern in Y is constant, this is a linear relation. Okay, it's a line. In fact, it's a flat line, a horizontal line. Okay, so let's have a look at this one, and I'm going to pick these points. So I can see that when I go up by 1 in X, I can already tell from the picture, from the graph, that it's nonlinear, okay, but we should really put a table to this. Okay, so I've got -1, 0, 1, and 2. Let's call that a half, 1, 2, and 4. That's nonlinear. Okay, because this is +1/2, +1/2, and then +1, +2. Okay, how about this one? This one looks a bit weird. Let's use a table. Okay, I think we should do multiples of 3. So let's go with 3, 6, 9. Okay, so when X is 3, I get 3 over 3 plus 4, which is 5. When X is 6, I get 3 over 6 plus 4, which is 1/2 plus 4, which is 4.5. And let's see what happens when Y is 9. X is 9. Okay, I get 1/3 plus 4, which is, this is 13 over 3. Okay, so finding the first differences, do we want to use decimals? We could, but I can see definitely that this is -1/2, and this one is not -1/2. We can figure it out by taking a half, subtract a third. Let's do it. So that's 3 over 6 minus 2 over 6, which is 1 over 6. So that subtract 1 over 6, and it is nonlinear. By now, you should have good intuition from the graph, and you can see that if you don't have a graph, if you have an equation or something, you can use a table of values. Okay, so the rest of the lesson is just with respect to lines, okay? So anything we do from now on in this lesson will be a straight line. So I know that the rate of change is constant. When I know that the rate of change is constant, and I know I have a straight line, we actually use a different word. We call it a slope, okay? And there is a couple of ways we can write down the definition of a slope, and you may have heard this. The slope is a rise or fall over the run. What are these? Again, this is just the pattern in Y over the pattern in X. It's the same thing that we just did. And what it measures is it measures not only sort of the steepness, but also the direction. Like we can see this is going up, up, and this is going down and down. And what I have done naturally is I'm reading my slope from left to right. Okay, so that's one thing we're gonna have to think about. So if I want to determine the slopes of this, what I can do is first look at the run. And by the way, just as I said, run always goes from left to right. I can see that there's one square there. And then my run is the change in Y values. So I can see that my run is +1 my slope is plus 2. It's going up. So my slope in this case is going to be plus 2 over plus 1. We can drop the plus. We can also drop the denominator of 1. My slope here is 2. In the same way, I can see that this slope has plus 1 as my run and plus 3 as my rise. It is rising. M equals 3. Okay? Now, again, I'm going to ask guys to keep in mind that the run always goes from left to right. So instead of going like this and like this, what I would recommend doing, it's not wrong, but what I would recommend doing is keeping your run positive from left to right. So this is plus 3, and now I have a fall actually. So my fall is minus 3. So I get my fall of negative 3 over plus 3. My slope here is negative 1. Okay, so what that means is it's decreasing with a fall of 1 when my run is 1. So I go across 1, down 1, across 1, down 1, across 1, down 1. Okay, same deal here. I'm not going to go this way because then it looks like a rise. I have to go from left to right with my run and then down with my fall. This is plus 2 minus 4. So my slope is negative 4 over positive 2, negative 2. Okay, so what we can see is that when I have a positive slope, it's going from left to right, my line is going upwards. When I have a negative slope from left to right, my line is going downwards, and that's going to be really helpful to us. So one way we can, if I don't have a graph, I can use an equation when I have 2 points on a line, and I'm just going to show you the equation. It makes intuitive sense if you look at what we just did, but let's just get right into some examples, okay?
So to explore this equation, what I want to do is start with the graph and show you how we're going to use it. So essentially, if I look at this slope, I know that from left to right, my run is 2, and my rise would be 1. So in the end, I know just by looking at the graph that my slope should be 1/2. Now, how do I use this equation to calculate it if I don't have the actual graph? What I need is 2 coordinates, and what I'm going to do is call this first coordinate A. I'm just going to write it over here. A is going to be 2, 1, and we'll call B 0, 0. And then what I want to do is designate these as x1, y1, and x2, y2. So for example, and I can choose either one, let's call B x1, comma, y1. And let's call A x2, comma, y2, meaning that, A is 0.2 and B is 0.1. And now what I'm going to do is just match up the variables in the equation. So y2 is the number 1. Okay, so, and for some reason, guys, we use m. I used it already here without thinking of it. We use the variable m to represent slope. I'm not sure why, but we're going to use it because that's what mathematicians do. So m, y2 is the number 1. Now, I have to subtract y1, which is 0. Now, if you think about it, if you look at what I've just done on the graph, I have found the pattern in y values. I've subtracted 1 and 0 to find the difference, okay, the difference in my y values, and that becomes the numerator of this fraction. Let's keep going. Now I'm going to sub in x2, which is this value. I'm going to put it in my denominator. And finally, I'm going to sub in x1, which is this value. here. And I can see that using my equation, I get the same value for my graph. So what I've essentially done is I've subtracted the x values. 2 minus 0 gets me a change of 2, a pattern of 2, and 1 minus 0 gets me the pattern of 1. So let's consider this other slope here. What I'm going to do is take any 2 points on the line, but I want them to be nice. So maybe let's take this point, and let's take, I don't know, this point. I could also take this point. It doesn't matter because this slope will give me the same answer as that slope. Maybe let's take the outer ones. So I'm going to use this point, A, negative 3, 3. I'm going to take this other point, B. Actually, I'm going to take this point as B here. I'll take B, 0, comma, 1. Let's sub it into our equation. So I get, let's call this one, and I can flip it around, it doesn't really matter. Let's call this one x2, y2. Let's call this one x1, y1. Okay, it doesn't matter which one I designate. It'll work out in the end. So I'm going to do y2 minus y1 over x2 minus x1, and I have to be careful with my negatives. So I'm going to get negative 2 in the numerator, and then 0 subtract negative 3 gives me positive 3, and that's my slope. Let's look at the graph to compare. So remember, my run always goes left to right. Okay, so I know my run is plus 3, and I do see that I have a fall here of minus 2, and that definitely works. I can see that it's consistent with the slope that I calculated. So why is this beneficial? Well, it's beneficial because I can now calculate a slope if I don't have a graph. I can just use my 2 points. So I'm going to call this coordinate 1, and I'm going to call this coordinate 2. And I'm going to sub in y2 minus y1, y2 minus y1 over x2 minus x1. Okay, I'm going to get negative 18 over negative 3, so my slope here is 6. Okay, that's a steep positive slope. For this one, let's call this 2 and this 1, and I just have to sub it into my formula again. M is y2 minus y1 over x2 minus x1. I get negative 1 over, and I'm going to do one step here, negative 4 plus 2, which is negative 1 over negative 2, and of course I'm going to cancel the negatives. Okay, so this is a positive slope, but it's not as steep. Okay, this one's a gradual slope. All right, let's call this 2 and this one 1. So I get 2 subtract negative 1. Negative 3 subtract 6. That becomes 3 over negative 9. I'm going to move the negative into the numerator. Okay, run should always be positive. So my denominator should always be positive. And in this case, I have a line that's going downwards from left to right, and it's not very steep because its slope is negative 1 over 3. Okay, last one here. Let's call this one and this one 2. Negative 7 subtract 5 over 1 subtract negative 2. I get negative 12 over positive 3. My slope here is negative 4, so it's going downwards and it's quite steep. Okay, so now that I know, more about what a slope is. Remember, a slope is rise or fall over run. What I can do is use my slope now and a point to graph a line. So in these questions, what I want to do is first start with an initial value. So here we have 1, 1. And then what I want to do is use my slope to find a pattern in my x values. So if I have a slope of 2, which I can write as 2 over 1, I can see that I have a rise of 2 with a run of 1. So what that means is if I go across 1, I should be going up 2, and I can draw a point there. And now I can follow this pattern to do the rest of these lines. And I can follow the pattern backwards too. Okay, so I can see all these points on my line, and of course I'm going to join it with a ruler. I'm going to fill the grid. And a good idea is to write in as many points as I possibly can. So now that we've done one, what I would recommend for you to do is pause the video, try to do all the next ones, and then check your answers against mine. Okay, good luck, and if you have any questions, please come and see us in Extra Help.